Hi everyone. In this video, we are going to explore how we can read different kind of files like CSV files, Parquet file, and JSON file into a PySpark data frame. So let's create a notebook first. Let's create this. Now, first we have to add data source here. So let's select one data catalog. So this lakehouse is now added here. So we can see in this lakehouse we have two data tables already created here, and in the file section we have different format of files. We have CSV files, we have JSON file, and we have one Parquet file also here. So let's start a session for PySpark. Great. So now, before starting this, we have to import all the PySpark SQL functions here. So let's first load that from PySpark.sql.functions import star. So we will use asterisk to import whatever functions are available over there rather than loading each function one by one. Similarly, for this tutorial, we need all the data types related functions also. We will import that also. Let's run this cell. Great. Now, first we'll load this customer CSV file. So let's see. So here we have three kind of paths here: copy ABFS path, relative path for Spark, and file API path. So if you copy this copy relative path for Spark, we can see this is the path. So this path is specifically navigating to files folder, and under that files folder we have this specific file. So for this tutorial we have to create a data frame. So let's do that. Let's name this data frame customer underscore df. So in order to read the CSV file, we'll use the Spark dot read dot format CSV. First option, we'll do the header true. Then again option, we'll do the info schema true. Then dot load, and here we will specify the path. So let's run the cell. Okay. So this is completed. Let's check the data frame. Let me make it big. Okay, so now this is our data frame. We have loaded this customer .csv file. We have loaded it here. Now, if you look at here, all the columns have specified their data type. For example, this is a text data type. For age, we have this numerical data type here. This is specifically a date data type, and this is 01 is a boolean data type, and again email is a text data type. So when we are defining infer schema true, so we are forcefully asking PySpark to read the sum of the rows of the data and identify what will be the data type for that specific column. And if we will not use this, let's check. If we will not use infer schema and if we do the display customer underscore df, see. So now age is now a text data type. Earlier it was a normal integer data type. So now if we are not doing infer schema true, so it's just loading complete data and making all the columns as a string data type. So let's again let it be. And what will happen for header true, if we remove this, let's remove this. See. So when we were declaring that header is true, so it means we were saying that okay, our data set had a header also, and the first row of the data set is our header. So when we are not doing header true, it is automatically assigning column names underscore C0, C1, C2, C3, C4 up to C10. So that's why we'll do the header as a true. So this is a one way of loading the CSV file, but we have another way also, which is a we can say a shortcut method to load the data. So let's try that. Customer underscore df. So now spark dot read, and now we can directly do dot csv, and then we can specify the path, and under this we can like mention all the stuff. Header is equal to true, info schema is equal to true, and let's display this also. So it is the same thing, just two different methods or ways to load a file over there. So one method is we'll do the spark.read.format, then we'll specify the format, then under the option, like first we'll do the header true, then info schema true, then we'll do the load, and then we'll update the file path over there. And in this we can directly do spark.read.csv, and we can specify the path, then we can specify everything here itself. So these are the two different ways, both are the same way. Whatever method you are comfortable, you can go ahead and just like load the file with that method only. Now there is another thing, when we were looking at here, there is a ABFS path also. So let's copy this ABFS path, and if I will check what is this ABFS path. So whenever we say ABFS path, so ABFS path is locating where the data is actually stored. So we can see it is 1 lakh fabric microsoft.com, then it has the ID, then it has the files folder, then customer.csv. So can we use this part directly here rather than using the this part? So let's try this. If we use this will also work. See, this is also working. So like we can do just a simple way, like copy relative path for Spark, and we can load the data here. And another way is, if we look here, we have the option of loading the data using Spark. So if we click on this, we will automatically get this spark.read.format option, header to dot load files customer underscore csv. So we can directly go here and we can click on load data, and we can load the data into Spark directly from here also. So now let's see, there is a customer underscore df, and if you want to look into the schema of the data set, we'll do print schema. So while doing this print schema, we are able to see like which column name and what is the data type of that particular column. The age is an integer, gender is a string, registration date is date. So we can, by using the print schema, we can check all the column names and what is their data type over there. Now, whenever we'll use this infer schema, so it will take a lot of process in the PySpark Spark itself to like read the data, then it will identify the data type over there. So it is a very process extensive we can say. So now rather than doing this, can we change the schema of the data itself, or can we like identify the different way of like identify the schema of the data set? So there is another way. We can like before loading the data itself, we can like make the schema of the data set itself, and we can use that over there. So now there is a method. The method we call it as explicit schema method. So by using this method, we can create a schema itself, then we can use that schema into while loading the data itself. So let's create that. So for that, we have to use StructType, and under the list we have to use struct So in struct we are mentioning what is the field name or the column name we can say. Then here only we are mentioning the data type. So for example, for this we want data type to be string type, and then after that whether the null is allowed or not. So if we say true, it will be true. Similarly, we have to do it for all the columns. So let's just copy paste it. So now the another column is first name. So if I will just copy the first name here, and yeah, obviously this will be string type. So similarly, we can do it for the complete data set, all the columns itself. So let me do it. Okay. So we are using struct field, then we are maintaining the column name, then what will be the data type. So this we are doing. So we have stored this schema itself in a new variable named as customer underscore schema. So now what we'll do, let's load the data set again. The format is CSV. This will be same. header true, header true. Then rather than doing option infer schema true, what we will do here, we'll use the schema, and under this schema we will use customer underscore schema here. Then as usual we'll do the load, then we'll write the file path. So now let's check the schema itself after loading the file. Okay, so by using this we can define the schema itself, like while loading the data itself, by using this structType method. And let me show you another thing. If I will change age as a string type, and let's do this, run this. As of now it is integer. If I run this, it will make each column as a string data type. So in this way we can explicitly define the schema itself. So let's run this, let's run this. So this is the first way of defining the schema, but sometimes like it take a lot of time to just write this. So there is a way we can get this. So if I will do customer underscore df dot schema, and if I will run this, see, this is the exact thing we are writing it here. This is the exact thing. So just for our convenience, what we can do, we can just copy this, and this is exactly the same thing. So whenever we have to define the schema, we can directly use this, and it will work. So let's just arrange it properly. So this is the exact thing that we are updating it here, we are making it here, we have to write each and every column name, then we have to write the data type. So this is the easy way, like just we can do the schema, and we can get it over there, and we can use that here, and we can change whatever data type we want whenever we load this particular data set. So this is the one way, and there's another way, which is DDL syntax method, we can say. So let's try that method also. So in this method, how we will define the schema. So if you remember SQL, how we define the schema, it is the exact same way. So let's, so in this method, we will be using just a SQL way of identifying the schema. So if I will copy this here, so yeah, so this is the way we are. So this is similar to SQL. We are writing the column name and whatever will be the data type, the same way we do in SQL. So that is why we can say it a DDL syntax method. So in this way we can define the schema in this, and okay, there's an error. My bad. Okay, so now if I will just use this schema, let's do customer underscore df. Now I will use the shortcut method to load. So we'll write the file path. We'll do the header equal to true. Now rather than using infer schema, we'll use schema is equal to customer underscore schema, and yeah, this will work. We can do the print schema here. So this is another way, and I think this is the easy way, like, and we are more familiar with this way of writing the schema. So we can use this method, or either we can use this method also. We can use both the methods, and for this specific method, whenever we need a complete schema and we want to have struct type and struct field, so we can use the schema method, and we can easily get that format itself, and we can adjust the data type according to our requirement. Now for this specific part, how we can get the schema in this format if we want to just get it. So there is a method. So it will do customer underscore df dot, so I will do jdf dot schema now to DDL. So this is the exact thing we are writing over there. So if you look at customer ID string, first name string, last name string, this is the same thing. Customer ID string, first name string, last name string. This is the exact thing. So if we want to define the schema using the DDL syntax method, we can just use this way, So it's a built-in way to get the to use the Spark Java utility and get the DDL syntax schema itself. So this is another way we can just copy it and directly use it here, and we can change the data type according to our requirement. So these are the way how we can identify the, like, not identify, we can define the schema. Now, so this is the how we can load the CSV data files, but let me show you the how we can load the JSON format data file. So let's copy the relative path. So let's name it order underscore dr equal to spark dot read dot format. Now here we have to write JSON because it's a JSON format file. Now we'll do load, and we just have to write the file path. And similarly, we can check by using order underscore dr. Yeah, see, this is loaded. So in the same way, we can define the header, infer schema. We can do all the stuff, whatever we are doing while loading the CSV file. We can do the same things while loading the JSON file. And let me show you, we have one Parquet file also here. So this is a Parquet file. So let's copy the relative path for Spark. Let's hide this. So let's name it. It will be similar. Just we have to do spark.read.format, and in the format we have to mention Parquet because it's a Parquet format file. Then we have to do the load. Then we just have to mention the file path, and yeah, we can use the display method of, and we can see the data. So in this way, we can load the Parquet format, JSON format, and we can load like whatever we are doing in the CSV format file, header, schema. We can do the same stuff in both the format files. Now, let me show you how we can read the data tables. So first, I have already explained like how we can read the CSV files, how we can change the schema, and how we can define the schema, and then how we can read the JSON file, how we can read the Parquet file. Now we have the data table and how we can read the data table. So there are some ways. So like, let me show you. So let's just use the customer df same way. I can do spark dot read dot table, and just we have to mention the name. It's a customer table, and if I will display customer underscore df, yeah, it's loaded. Now there is another way, like let's load the marketing spend here. Spark dot, you can just do the spark dot table, and you can write the name. You see, you can see the name here, marketing spend. So see, now this is also loaded. So these are the two ways. We can do spark.read.table, and we can also do the spark.table, and we can just mention the whatever is the table name. And there is another method to load the table. I can say load the data table. Let's again name it customer underscore here spark.read.format, and now we will mention the data here, and then we'll the table, then it's a customer table, so just we can select the customer table, then we can do the display customer underscore df. So we can run this. So now this is also loaded. So whether we are using the spark.read.table, whether we are using the spark.table, or whether we are using the spark.read.format delta dot table customers, we are reading the same delta tables. There is no difference. We can use any of the method, and if we want, we can just go here, click on this, then and click on Spark, and we will be able to see that we will be able to load the data here. And now this is another way of loading the data by using the spark.sql method. So in this method, it's simple, like we are using spark.sql, and then we are writing a normal SQL query, like our usual SQL query we are writing, and we are saying select star from, like, so this is the path actually, global supply chain lakehouse. Then under that there is a DBO, then under that there is a customer table. So we can load using this way also. So these are some of the ways to load the data, to load the file, and to load the data tables. Also, like there is another way. If there is a table and we want to just load it directly, so we can change the Spark SQL here. So now we have changed it to Spark SQL. There is a magic command, and now if I will write select star from customers. So by changing this to Spark SQL, or even if we are not changing this, and it will just come here, we'll use the magic command, and it will write select star from marketing stand. We will be able to read the tables itself, and we can write our usual SQL query, whatever transformation we want to do, we can do using SQL itself. So these are the some ways. And now, like, this is how we can use the SQL here directly from like Delta table. And now let's take another scenario. Let's just use this file itself. Okay, so let's close this. Let me just copy the top one. So now if we want to use SQL here, like there is another way. We can create a temporary view itself. So we can do the customer here dot create or replace temporary view. Then let's call it VW customer. Now run this. Now what we can do, we can use this, and we can say from VW customer limit 10. So if we have loaded any CSV, JSON or Parquet format file into a Spark data frame, we can create a temporary view and then we can use the SQL over there, like after creating the temporary view. This is another way. And like if we directly want to use like SQL in the data frame itself, like, or so this was the way, like we can do the spark.sql, and we can write query here itself, and bw customer unit 10. So if we want to display it here, so like sometimes some transformations, like if it's for us, if it is easy to do using SQL, we can either create a temporary view, we can try it out with the SQL, or we can just use the spark.sql, and we can load this into another data frame itself. So these are some of the different ways. Now let's take a scenario. If we want to load all these data frames in, like, if we want to load all these files in different data frames, each time we have to go it here and we have to load the file into the Spark data frame itself. So there is another way to do this. So let me show you how we can do this. So we have a built-in function. It is under this, it will do fs.ls, and under this we know, like under files we have a all the files. If we click on this, if we run this, we'll get all the file info, whatever is the path, the complete file path, what is the name of the file, what is the size of the file. So, and you can see this is a list. This is a list. So, like it's good, it's a list, so we can loop over it. So, if I will loop over it, let's copy this for time. So, if I will do print, let's try I only. So, while doing that, we are able to get file info for each and every file, but we either need the complete file path or the name. So, if I will do dot path, so now we can, using this, like we can literally iterate over each and every file path itself. And if I will do dot name, so we will have the names of the files itself. So by using this, we can like create a for loop itself, and we can iterate over all the file path, all the file names, and we can load it into the data frames directly itself. Rather, like just think in that way. If we have 100 files here and we have to load all the like files into the like data frames, or even like 5, 6 files is there, 7, 8 files is there. There's a this way, like different way we can do this. So let me show you how we can achieve this. So let's create a for loop for this specific purpose. So let's do for file in this ss.ls, and this is going under files. Now first we have to have the name of our data frame. So what I can do, so whenever it will go like iterate over every, so for example this is the first file, so now I need the name from this, so I will do dot name, and after this I want to split it by dot. Why I'm splitting it from this dot? Because you can see the name here is customer.csv. So then what will happen, it will split it out, customer and csv, inventory and csv, it will split out. So even if I will run this here, see the customer, and now this is a list. So in the list I want this specific name itself, so I have to do it here 0, because the place value for this will be 0 and this will be 1. So even we can check it out here. If I will write 0, see I will have the names. So same way I'm doing it here while creating a for loop. And now the another thing is we have different format of files. We have CSV, we have JSON, and we have Parquet. So what we can do, we can do if file dot name ends with dot CSV. If it is ending with dot CSV, then we have to mention globals here so that it will be available over this notebook. Then we want the name will be, we will use f string here. The name will be the df underscore name. So if it's a customer, we want the name to be customer underscore df. So df. And now it's a CSV file. So we'll use the as usual spark.read option header true for schema true CSV, and here we'll use file.path. So this is for a CSV, and then we'll use elif. Let's copy this completely and paste it here. Let's make it elif. Okay. So if the file name ends with, this time we will be doing this for JSON. So here we'll just do this spark.read.json and just a file path. Similarly, we can do it for Parquet, and we can just change it to Parquet. So this looks good. So what will happen? It will iterate through all this, and here we are defining the name, and we are splitting out the whatever is the file extension over there, whether it's the .csv .json, we are splitting it over there, and then we are writing just a if else condition, like if the file is a CSV file, then the created data frame it will read like a spark.read.csv thing, and if it's a JSON, then it will read using the JSON method, and if it's a Parquet, then it will read using the this spark.read.parquet method. So let's run this. Yeah, it's run. So now if we want to use like any of this, so we can just write, let's write something else, inventory here. We can use the display method, and so all the data is loaded. But if you want to check, so we can check using this under globals dot items. if we'll run the name, this will not work. So for name and object in globals.item, I think we have to do it name dot ends with underscore df, then print the name. Okay. So using this, we will be able to see like what are the data frames we have created, like, or whatever in this notebook is there, which is ending with underscore df. So here we can see like there is a customer underscore df and there is another customers underscore df. So this customers underscore df is created when we run this for loop, and that customer underscore df, that is when we started working on this and we have created this customer underscore df. So by using this method, we can load multiple files, multiple formats of files directly by looping over it.